Okay, folks, we're now back online, folks. Can we please focus on the question? Okay, right. Right, okay, we are now back online. Please focus. Okay, this part of the question hasn't come out too well. So it's Rihanna. Okay. Okay, right, are we ready, folks? Okay, right. Right. So Rihanna plays a game. The probability that she will lose the game is 0.32. The probability that she will draw the game is 0.05. Rihanna is going to play the game 200 times. Work out the estimate for the number of times Rihanna will win the game. So they give us probability for losing, drawing, but they didn't give us for winning. So 0.32 at 0.05 gives us, and all the probability should add up to 1.00. So that was the remaining one. So the probability of winning is going to be 0.63. Okay, so we've established that first of all. So to work out the probability for the noise, can you stop it now, please? Yeah. Probability of losing is 0.32. Probability of drawing is 0.05. That gives the total probability of 0.37. So now we can work out the probability of winning, which is 0.63. Now, work an estimate for the number of times Rihanna will win the game. She plays the game how many times? 200 times. So she plays the game 200 times, and the probability of winning the game is 0.63. Now, to work out 0.63 times by 200 with our calculator, first of all, we get the 0.63 we multiply it by what? 100. Because multiplying by 200 is the same as multiplying by 100 then multiplying by 2. So 0.63 times by 100 is 63. And then we have to multiply it by 2. So we got 63. And then multiply by 2, the answer is?
126. 126.
Okay. And then, so probability of her winning the game will be 126 times, and the 200 times is spread it away. Okay? Okay? So what we're going to do, we got 2 more of these little pictures left. Okay, let's get the next one. That's it for that part. That's it. And then here comes the next one. So bring the picture over. Okay. Okay, here we go. Here's the next question. Right. There are only red, blue and white counters and black counters in the bag. Red, blue, white and black. The table shows the probability that counter taken random from the bag will be red or blue. The number of white counters in the bag is the same as the number of black counters. Okay, Tanya takes at random a counter from the bag. Work out the probability that she takes out a white one. Now, we know the probability of a white and the probability of a black are both equal to each other. So first of all, we do 0.2 add 0.5 to work out what we've got so far.
0.7.
So that gives us 0.7. 0.7 add both of these. 0.7 add 0.3 is equal to
1.
So these two must add up to 0.3, and because they're both equal, we is half 0.3, and that gives you 0.15 each. Now, okay, work out from this here. So white counters, that's going to be what? 0.15. Okay, the next question on the bottom of the picture, on the bottom of our board here. Yes, there are 240 counters in the bag. Work out the number of red counters in the bag. So it's 240. Multiply the probability of red, which is 0.2. Okay, now 0.2. At the moment, this is again, this is non-calculator. So don't think about using calculators. So let's give you a technique for dealing with this question without using calculator, just using the brain that God gave us. Okay, so 0.2 as a fraction can be written as nicely as 2
2/100.
tenths. 2 tenths. Now 2 tenths is a nice number because if we divide that by 10 and divide that by 10, we cancel them off. Makes the situation much nicer. So we've got 24 times by 2, and 24 times by 2 is
48.
48 is the answer. So we expect to have 48 red counters. That question's done. Okay, here comes the last one, which I've got here with the picture of it.
6.
Oh, this one's a nice one. You know what that means, don't you, folks? And that is a nice one. Oh. Show me tumbles. Oh, that's nice. Question number 26 with the line through it. Pfizer? Fizzer. She's fizzing. Pfizer. Okay, Pfizer, she's fizzy. Pfizer has 10 coins in the bag. There are 3 £1 coins and 7 50p coins. Okay, right. Pfizer, we just call it fizzy. Pfizer takes a random 3 coins from the bag. Look at the probability that she takes exactly £2.50. How do you make £2.50 first of all? With those coins? With 3 coins?
£1 and 50p.
Is there any other way of making that's it then? Okay, so let's have a look. So the probability that she will make exactly £2.50 is equal to the probability of a £1 and the probability of a £1 and the probability of and the probability of a 50p.
So can't you do 4 50p's?
Remember, you only use 3 coins. That's the condition. Okay, folks, is that the only way we can make £1, £2.50?
£1 and 3.50.
So we can change the order of these, can't we?
Yeah.
Have a different order, yeah?
150.
So or we can have probability of a
P1.
1 and 50p and 1. Or we can have the 50p first, followed by a pound, followed by another pound. So look, £2.50, 150, 250, 150, 250, yeah? Okay, just different ways of doing it. Now, she takes them out of the bag, so as you put them back in? No. So this question is going to be with or without replacement? Without replacement. From the nature of the question, she's taking them out of the bag, she's making £2.50. She's not taking out, looking at it and putting it back in again. She's taking them out. So the probability will change. So how many coins we started with first of all?
3 10.
So we're going to have, first of all, 10, followed by a 9, followed by a 8. Because each time the coins are getting less. So we're going to be out of 10, out of 9, out of 8. Out of 10, out of 9, out of 8. And we said that the O means
Add.
And O means add. Okay, now, I have out here a probability of 1 plus the, actually what I meant here, a bit of a correction here, I was thinking about adding the money, and probability of a £1 and a 50p and a 1. So can you please replace the pluses with an and, because in probability the plus means something else. But I didn't mean plus in probability terms, I was talking plus in terms of monetary terms. Alright, so that's better now, that's correct. Okay, what's the probability of getting a £1? How many £1 do I have? 3. So I've got 3 chances of getting a £1. And means times, and means times, and means time, and means times, and means times, and means times. What's the probability of getting another £1 out?
2.
Probability of getting the first 50p out?
1.
Now how many 50p's do you have?
7.
7. Okay. What I could do, just to make that look a bit different because it's a bit too close. I'm just going to change the colour, folks. Don't worry, I'm just changing the colour. So what was the first one here? What was it?
3, 2, 7.
3,
2,
2,
7.
7. Good. That's a better colour. What's the probability of my first pound if I do it again? First pound is
3.
3. And the second, and the probability of the first 50p is
7.
7. And the probability of the second pound is 2. Are you happy with that, Idris? Harun? Good. Come on, you with us? Probability of my first 50p is
7.
probability of my first pound
3.
3. And the second one
2.
2. Okay.
42 of
Peter, can you check if that's clear? Try to picture that, not fuzzy. That's clear? Everything up there? See that, man? Good. Okay, now we've got to work this out. So 3 times by 2 is?
6.
6 times by 7 is?
72. 42.
42. Okay. 9 times by 8 is? 72 times by 10 is?
720.
Okay, have we got the same numbers running each time?
Yeah.
And the bottom numbers the same?
Mm-hmm.
Okay, here we go. So that gives you 42 over 720 and that gives you 42 over 720. So 42 at 42 at 42 gives us on top?
126.
That gives us 126 over
72.
720 stays the same on the bottom. So you can cancel this down if you want to, folks.
7 over 40.
So you can cancel it down. But we can leave it just like that as well. So if you cancel that, it comes down to 7 over
40.
That's after dividing by whether you divide by 2s or by 4s each time.
I don't want to.
Yeah? Okay. 7 over 40 is the final answer. That's if you simplify it. Both these answers are perfectly acceptable. Okay, I think we've got one left.
That's it.
Is it the last one?
Yeah.
Okay, that's right. Now, what you need to do, folks, now the two pages at the back which have got the same questions again on them, can you now try them yourself, please? Okay.